So I wanted to go through and just kind of review what we've done so far with energy. And if you remember, our idea is that energy is this number that at the beginning of a process and at the end of the process it doesn't change value, but it does change where it's stored. So for example, if I start off with a ball that's really high up, all of the energy is gravity, and then as it falls, with air resistance and with it picking up speed, all of this gravity energy gets transformed into kinetic energy and dissipated. That's sort of what we've done so far. If you remember, we actually named 4 types of energy that we actually are going to worry about in physics class. And here they are listed right here. We've got kinetic, which means that we're moving. We've got gravitational, which is related to the height of an object, assuming that we're on Earth. Elastic energy we're going to talk about next week, but it has to do with springs. We've described it a little bit. And dissipated energy is kind of the most interesting one. It's the one that's lost to friction or heat. So we shouldn't say it's lost. What it means is that, for example, when this ball falls and there's dissipated energy, the air molecules remove energy from the ball, and now the energy of the ball is now stored in the air molecules as they heat up just a little bit. So we're going to get into springs next week. And what we were able to do this week was we were actually able to talk about kinetic energy in terms of formulas and gravitational energy in terms of formulas. If you remember our formula for kinetic energy, 1/2 mv squared, where this is mass, this is speed, and of course when we get into gravity, m is still mass, g becomes gravitation and acceleration, so gravity, we'll just call it that for short, and h becomes the height. And so we were actually able to solve a number of problems that way. For example, one of the problems we were actually able to solve was that we actually had 2 carts colliding, one going this way and another that was still. And of course we started off with all kinetic energy, and then it became kinetic plus dissipated energy. That was what we did in the lab. And then a second kind of problem that we did near the end of the week was we'd have something like we have a ball and it's at, say, a height of 2 meters, and it's got a mass of 2 kilograms, and we want to know its speed when it hits the ground. And we'll assume that 10% of the energy is dissipated. That's the kind of problem that we did before. Now, we used energy bar graphs to actually trace what happened to the energy. Remember, we'd use these bars. So for example, in a problem like this, we'd say, well, let me just give this thing 4 bars of kinetic energy. And then when we looked at where the energy went, whoops, draw that a little bit more even, we'd say, all right, now as this thing hits and sticks, we're going to actually lose some of our energy. So we start off with originally all kinetic energy here. And then what happens is it gets split between kinetic and dissipated. We kind of did that in class. And then for a problem like this, even though the numbers are going to be different, whoops, we find that the bar graph approach is the same. We just got to make sure we put the energy in the right places. So for example, in a problem like this, we're going to start off with, I'll make it 4 bars of gravity energy. And of course what happens at the end of this problem is that this energy gets converted into kinetic, and we'll just put 1 bar of dissipated here. And we set up equations. We said, for example, in the first case, E kinetic equals, gets converted into E kinetic and E dissipated. And here the gravity energy gets converted into kinetic plus dissipated. So what you're actually going to do in the Google Docs is I'm going to actually have you solve the problem for these numbers as your homework. And that's a summary of what we've done so far with energy.